Okay, welcome to part 2 of the fall semester review tutorial. Now we're just going to go over random questions from the review. Okay, yes, what's your question? What number? Sig Figs, which is number... Okay. You need help with calculating Sig Figs also? Okay. So the question is about Sig Figs. Okay, I'm going to go ahead and ask that your respect and other people's questions. If you want to have a personal conversation with your neighbor, you can step outside. And here we're going to do a tutorial, so we're going to answer people's questions. Okay. So the question was about Sig Figs and how to count the number of them, right? Okay, so with significant figures, the whole issue is when does a 0 count and when does it not count, okay? So it's actually probably a lot more simple than you think. My method for counting Sig Figs may be different than what you've been shown, so let me show you my method, okay? My method for Sig Figs is you first underline the first non-zero digit, meaning digits 1, 2, 3, 4, 5, 6, 7, 8, 9. So it can't be a 0. So the first one I see is this 1. Do you agree? Okay. The next thing I'm going to look for is a decimal. Does my number have a decimal? It does. So because it has a decimal, everything including all the zeros count after that digit that's underlined. So this would be 1, 2, 3, 4, 5 significant figures. I call these guys sandwiched zeros. Sandwiched zeros always count, okay? Okay, so for number 18, we can do the same exact thing, okay? I'm going to underline the first non-zero. Is there a decimal? Yes. So because there's a decimal, everything after the first non-zero counts. So this would be 3 sig figs. For number 19, we're going to underline the first non-zero, which is what number? Okay, 5. Is there a decimal anywhere in the number? Yes. It doesn't matter the location of the decimal, it just matters that there is one. So everything after the first non-zero counts. So this would be 3 sig figs, okay? We call these guys leading zeros. Leading zeros do not count. Does that make sense, kind of? Okay, let's do these other examples really quick. These are in, that one's in scientific notation. Okay, so we're going to underline the first non-zero, which is the 5. Again, there is a decimal, so all of the digits after the 5 count. 1, 2, 3, 4, 5 significant figures. Do you see how that works? In my opinion, I think that's easier. Okay? I think it is. Yes, what's your question? If there's not a decimal, let me make one up in a second, okay? I'll make one up without a decimal in 1 second, because, yeah, you're right. All these have decimals. For 21, this one's in scientific notation. The rule for scientific notation is everything in front of the times 10 counts, okay? So 1, 2, 3, 4, 5, whoops, 1, 2, 3, 4, 5 significant figures. Okay, so if there's not a decimal, let's say that's my digit, or that's my number, okay? So I underline the first non-zero. There's no decimal, so the zeros at the end don't count, okay? This would be called a sandwiched zero, so it does count. So this would be 3 significant figures, okay? So these numbers count. The reason those zeros don't count is because there's not a decimal. Okay? And the reason is decimals give you very exact numbers. Without a decimal, we're assuming that's rounded. Like it might really be 30499. You see what I'm saying? Because there's no decimal, it's probably just rounded up. That's what we assume. So we would say that's 3 sig figs. Does that make sense? Okay. If there's another example you can make up in your head that you want me to do, I can do that. Okay? I saw a hand right here, and then I'll get to y'all. Was it about this type of thing? Yes? Okay. It means something, but you just don't count them when you're dealing with sig figs. You see what I'm saying? So the exponent, because it's a positive exponent, means this is a really big number. But if you're counting sig figs, you don't consider that. Does that make sense? It does? Okay. Ashley, you had a question. Yeah. So once I put a decimal right here, all of a sudden it counts. 1, 2, 3, 4, 5. You see what I'm saying? But without a decimal, it doesn't. And actually, even if I put the decimal anywhere, it counts. So if I put the decimal here, all of those still count. You see what I'm saying? Because there's a decimal in the number. Oh, okay. I wanted to finish with Sig Figs first. Okay? I promise I'll get to 26, though. Yes. Yes, I wanted to finish with the Sig Figs. So let's do a couple more Sig Figs, and then I promise I'll get to your question. Okay. Let's just do 2. So let's do number 22, and let's do number 24. Okay? So with this one, we're adding or subtracting. The rule for Sig Figs, if you're adding or subtracting, you round to decimal places. Okay? So first I need to add this together in my calculator so I have a number at least. So adding these together, am I adding? Okay, good. 13 plus 45.33 plus 9. Okay, so what do I mean by decimal places? That's kind of important. Decimal places are digits after the decimal. So if we look at this number, how many decimal places does it have? Just 1. How many decimal places does this have? 0. How many decimal places? How many decimal places? What is the least amount of decimal places? 0. So I want to round my answer so it has 0 decimal places. Do you see what I'm saying? So my answer comes out to 133.03. But it's important I round this to 0 decimal places. So when I round, it's just 133. Okay? Now, if this number was 133.5, it would round it up to 134. But because this is a 0, it doesn't round up. Do you see what I'm saying? Does that make sense? Yes. Okay. So then with something like 24, if you're multiplying or dividing, this is when you look at Sig Figs, meaning like the whole digit. So in the number 15, how many Sig Figs in that digit? That number? 2. How many Sig Figs in the number 4? 1. So when I do 15 divided by 4, I get 3.75. I want to round to the least amount of Sig Figs, so my answer can only have 1 Sig Fig. So the 3 is going to be your whole number, but I can round this up because behind it, it's bigger, it's 5 or bigger. So it's actually going to be 4. That'll be grams per milliliter as the unit, because it's grams divided by milliliters. Does that make sense why I rounded that way? Yes? Are you sure? Least number. Yep. If you're adding or subtracting, least number of decimal places. If you're multiplying or dividing, least number of Sig Figs. So you consider the whole number, not just the decimal places. Does that make sense, the difference? Yes? Awesome. Okay. What was your question again? 26. Okay. So we can move on to scientific notation. All right. So 26. Convert to scientific notation. So with scientific notation, you have to have a number and then a decimal. So, and it has to be a number 1 through 9. Okay, it can't be like 0 point something. So you're going to move your decimal so that you have 1 digit in front of the decimal. So I'm going to move it 1, 2, 3, 4 places. Yes? So it'll be 9.89 times 10. And your exponent's going to be a 4. Now the question is my exponent positive or negative? I think I teach this kind of differently too. Okay? A positive exponent means big number. A negative exponent means a small number, meaning it's less than 1. Okay? So is this a big number or a small number? Small, so my exponent's negative. Does that make sense? Big number would be greater than 1. It's 0.000987. Do you see what I'm saying? The original number. Does that make sense? The original number. Yes, sir. It's okay. Good question. I bet this tutorial is going to be really confusing because they can't hear your questions, but it's okay. Sorry, people at home. Okay, so let's do B. All right, does everyone see how B would be a really big number? So this would be a positive exponent, okay? Now, oh, here's a good question. For B, where is my decimal at? Okay, at the end. Believe it or not, I get asked this a lot. So if the decimal's not already there, kids will be like, where's the decimal at the end? Okay, so I'm going to move it 1, 2, 3, 4, 5, 6 times. So it's 8.7865 times 10. How many times did I say I moved it? 1, 2, 3, 4, 5, 6. So 6th power, and it's positive because it's a really big number. Does that make sense? Do you want to see them in reverse too, like number 27? Yeah? Okay. So with number 27, you kind of have to flip your brain a little bit, okay? So this is really what I look at. My exponent is negative. So because my exponent's negative, that means I have a small number. So move your decimal to make the number small. Don't move it to make it big. So use some common sense, all right? So we're going to move it 3 places to make it smaller. So it's going to be 0.00445. Does that make sense to you? Okay. And number B, or letter B, I have a positive 2. So I'm going to move it 2 places to make the number bigger, 600. You don't have to. If you did, it would not be wrong. Okay, the question was, do you have to put a decimal after the 600? You don't have to put a decimal after it, but you can. It won't make a difference. It makes a difference in Sig Figs, but not in scientific notation. Okay, what other questions do you need help with? Any question from the review at all? Yes. Alpha and beta. Oh, yeah, that's right. I forgot. What numbers are those? Okay. Okay, she asked about question 71, which is alpha and beta reactions. These are actually pretty easy if you can remember what an alpha particle and what a beta particle are. Okay? So, alpha particle. The alpha particle is a helium nucleus. You kind of just have to memorize this, okay? So it's helium, and then the top number is 4, the bottom number is 2, okay? The beta particle is what we call a high-speed electron. The top number is 0, the bottom number is -1. Okay, so what happens in these alpha and beta reactions is they release either an alpha particle or beta particle, and then a new, more stable isotope is formed. So you have to show me both in the reaction. Okay, so since it tells me this is an alpha decay reaction, I want to show my alpha particle being formed. But then I also need to show this new, more stable isotope. Well, how do I figure out what that is? By subtracting, really, okay? I need this side to add up to this side, okay? So what plus 2 gives me 42? 40. So the bottom number is 40. What number plus 4 gives me 96? 92. So do you see what I'm saying? These added up should equal this side, okay? So then by the bottom number, you look it up. So I'm going to look on my periodic table for number 40, which is zirconium. So I'll put Zr as my brand new stable isotope. I may even ask you what they are. So you would have to know this is your alpha particle and this is your more stable isotope found. Does that make sense? Mm-hmm. Okay, so the question was that the masses aren't the same. Okay, so the mass is the number on the top, right? This is called the mass number. So this is a very small detail, but it's important, okay? Mass numbers are specific for isotopes, okay? What you're seeing on the periodic table here is the average atomic mass of the different isotopes. So there's more than one zirconium that exists. Does that make sense? So it's the average on the periodic table. What we're looking at here in this reaction is just one isotope. Do you see the difference? Awesome. Do you want to see a beta? I'm going to do one anyways because it's negative, so kids mess it up. Okay. I won't ask you to do a gamma. Okay. So with beta, it releases a beta particle. It releases a beta particle, and then this new stable compound has to add up to the other side. So what should this bottom number be? 93. Very good, because 93 plus -1 gives me 92. The top number is still 238. So when I look up 93 on the periodic table, 93, where is it? NP, Neptunium. Any questions about alpha beta? Yeah. About something different? Okay, what's your question? Number 66. Find the average atomic mass. Okay. So I've been asked this question a lot today. Okay. So please close your personal conversations. Pay attention. Okay. Average atomic mass is the thing that we actually find on the periodic table. Okay. So when you're getting the average atomic mass of these different oxygens, you're just going to multiply and add. So here's the mass, 15.99, which is what we see on the periodic table, times the percentage. Okay, so this is a weighted average. So that means 99.8% of oxygen is this mass. Now, I can't just multiply by 99.8. It doesn't work like that. You have to put it in decimal form, so 0.998. And to get that, all I did was divide by 100 or move my decimal twice. Okay? Plus the next one, which my next isotope has a mass of 17.00, times the percentage, so I move the decimal twice, so it's 0.004, so it's got 3 zeros. And then plus my last isotope, which is 18.00, times its percentage, so again move the decimal twice, and you should get your answer. Okay? And it has to come out to 15.999 because that's what we see on the periodic table. Questions about how to do that? You would calculate your grade the same way. So you could say, like, my average on quizzes is 100 times the weight, because quizzes are only 30%, right? Plus the average of your tests times 0.55, which is 55%, which is your test. This is actually how your grade is calculated, because it's weighted. And the reason is tests aren't worth as much as daily grades, or are actually worth more than daily grades, right? So we can't just add them together and divide by 3. It doesn't work that way. Do you see what I'm saying? Okay. What other questions do you have for me? We still have 26 minutes to answer any question off the whole review. $88? Okay. Okay, question 88. Okay, an acid. So how do we write this acid's name? This is a good question. That's a polyatomic ion named acetate. So remember the rule is what I ate was icky, so this will be called acetic acid. Okay, so polyatomic, the word poly means many. Atomic means atoms. So this is many atoms. It's actually 2 plus 3 plus 2, which is 7 atoms, right? So if you look on the back of your periodic table, you can find acetate. It's actually the very first one. So it should match that, C2H3O2. You see what I'm saying? So I know that's acetate. The ending changes to ic for an acid, so it's acetic acid. You had a question. 73. How can ionic compounds be recognized? What type of bond do they form? Okay. So they can be recognized by what they're made of, okay? So an ionic compound will either be a metal plus a non-metal. So something simple like sodium chloride. This sodium part's the metal, the chlorine is the non-metal, right? What gets complicated with ionic compounds is the metal or the non-metal can be replaced with a polyatomic ion. Okay, so what I usually do is I'll draw a little arrow and put poly. So like this could be ammonium and this could be chlorine, and that would still be ionic. Or this could be sodium and this could be phosphate. It's still ionic. Do you see what I'm saying? So metal plus a non-metal is kind of the standard. And then remember that either one could be replaced with a polyatomic ion. And they have an ionic bond, original. That's the name of the bond. Does that make sense to you? Yes? Okay. What other questions do you have from the review? Anything from the whole review? You can ask me anything. Yes. Which one? 96? Oh, molar mass. Okay. This is a good one. Okay, so we're trying to find the molar mass of calcium phosphate. Okay, so this is actually really simple. It's just sometimes kids forget how to do it. So what makes up calcium phosphate? Calcium, phosphorus, and oxygen, right? Those are the 3 different elements. There's 3 calciums, there's 2 phosphorus, and there's 8 oxygens. So notice that that number outside of the parentheses multiplies in, okay? So I'm going to take that, I'm going to multiply it from its mass on the periodic table, and I'm going to add them together, okay? So I'm going to use a periodic table at my desk. You can look at the one that you have. Calcium is 40.078. Phosphorus is 30.974, and oxygen's 15.999. So what I'm doing is I'm multiplying these out, then I will add all those numbers together. You can kind of do that neatly in your calculator by using parentheses, okay? So when I do that, let me turn. I get 310.174. Okay, and that would be grams per mole is the correct unit when they're asking you for molar mass. Yes, ma'am. 107, okay. Okay, the first thing is you want to make sure, and this is a correction we made later, cross out the V's and put F's. They should be F's, yeah. The V's on page 6, you see how yours have V's? Technically both are correct, and we just kind of switched that unit this year. It still means frequency. It's just kids recognize the F better, right? Okay. So 107. Gamma rays have frequencies around 110 times, I can't read, 1.0 times 10 to the 21st hertz. What wavelength does this correspond to? Okay, so they're giving me the frequency. So this is F, and they're asking me to solve for wavelength. This little symbol, which is lambda, is for wavelength. Well, I can figure that out by using this equation. But what I need to do is rearrange the equation to solve for to solve for wavelength. Okay. So how do I rearrange that to solve for wavelength? It's not hard, so let me show you. I have C equals wavelength times frequency. I want wavelength to be on a side all by itself. So what's with it that I need to get rid of? Frequency. So I'm going to divide both sides by frequency so I can get rid of frequency. Now I have the lambda or wavelength by itself, so it's C over F. Does that make sense to everyone? Very simple to do. So just plug everything in. C is the speed of light, which is always the same, 3.00 times 10 to the 8th, divided by the frequency, which is 1.0 times 10 to the 21st. They gave that to me. Put it in your calculator, and you have your answer. Okay? So 3 times 10 to the 8th, divided by 1 times 10 to the 21st. And I get 3 times 10 to the negative 13th. And because I'm solving for wavelength, the unit is meters. It's not. It's always going to be meters. What was your question? Huh? You are somehow putting it in your calculator incorrectly. If you want to come up at the end, or he can show you, I can show you how to put it in the calculator. And it depends on your teacher, because teachers show kids how to put it in calculators differently. So I can help you in a little bit, but I don't want to ask who your teacher is. Okay, I saw him first, so then I'll get to y'all. Yes. Yes. What number is it? It just takes us a few steps, huh? 104? Okay. 104. Okay, so this should be one of your favorite things to do because it has a corny little poem that goes with it that hopefully you've memorized. Maybe I'll make y'all say it just for fun. Okay, so here's the poem. You ready? It goes, percent to mass, mass to mole, divide by small, multiply to whole. Okay? So this is how it goes. Percent to mass, mass to mole, divide by small, and multiply till whole. Yay! Those are your instructions. If you can memorize that corny poem, it's going to tell you exactly what to do. All right, so let me show you the steps. And I have a whole tutorial video over explaining exactly how to do this. All right, so how do we go from percent to mass? Very easy. You cross out the percent signs and you put G's instead. That's going from percent to mass. Step 1 is done. Then you have to do a one-step dimensional analysis to go from grams to moles. So I'm starting off with 40 grams of carbon. To go to moles of carbon, I use the molar mass. So you look at the periodic table, the molar mass of carbon is 12.011. That goes on the bottom, 1 mole goes on top. Okay? So 40 divided by 12.011 is 3.33. Okay? You have to do this for every element that they give you something for. So 6.7 grams of hydrogen. I'm going to do it a little fast to save time. 6.7 divided by 1.008 gives me 6.65. moles. And this one's of carbon, this one's of hydrogen. My last one is oxygen. So 53.3 grams of oxygen. Converting oxygen to moles. I'm just using the molar mass to do this. Get 3.33. Okay. So this is going to be the longest step, is step 2. Okay, just be prepared for that. Going from grams to moles takes a minute. Okay, so then you divide by small. So do not overthink this. What is the smallest answer of the 3 that I just got? Okay, so what's smaller, 3.33 or 6.65? 3.33. Okay, so it says divide by small. So you're going to divide all of these by 3.33. So you get pretty numbers. We get a 1, we get a 2, and we get another 1. Those are the coefficients in the compound. So that means I have 1 carbon, I have 2 hydrogens, and 1 oxygen. So it's CH2O as your final answer. Huh? That if you don't get whole numbers, that's where you multiply till whole. We're only going to give you like a 0.5 decimal, so you would multiply by 2. You'd multiply all of them. Yeah, so what you do to one number, you would have to do to the other. So if you had to multiply to whole, you do it to all of them. Yes. Okay? Does that make sense? Okay, I saw hands. I just don't remember who asked questions. Was it you that had a question? Did you have a question? Yeah. Frequency. Okay. What number is that so I can show you? Okay. All right, guys, please quiet down till I'm done, please. Okay, so the difference between frequency and wavelength. I'm going to draw 2 different waves. Okay, so wavelength is the space between 2 high points or 2 low points. That is your wavelength, okay? So here we would say this has a long wavelength. Down here, these would be very short. Do you see what I'm saying? So this would have a small wavelength. Frequency is how often you see the waves. So because these are long, we don't see very many of them. So this would be a low frequency. This, because they're very short, we see a lot of them. So this would be a very high frequency. Does that make sense? Yeah? Okay. What other questions do you have from your review? Anybody? Questions from the review? Yes. Just the orbital part? 109? Okay. Oh, list the number of orbitals contained in the following sublevels and how many electrons. Okay. Okay. So we said this is the S block, right? Okay. In the S block, it's a 2 electrons wide, okay? And on the periodic table, it not only increases by the number of protons, but by the number of electrons, because protons and electrons are equal. Does that make sense? So we would say this is 2 electrons, okay? Since 2 electrons fit in 1 orbital, we would say that this is 1 orbital. Does that make sense? Okay. Then if you're looking at the P is 6 electrons wide. Do you agree? Okay. But if 2 electrons can fit in 1 orbital, then I've got 1, 2, 3 orbitals. And it kind of continues like that. On this one, 10 electrons. Whoops. I went too far. Okay. So this is 10 electrons for the D block, then that's 5 orbitals. Do you see what I'm saying? So was always half. Other questions? 111? Okay. 111. Write the electron configurations and orbital diagrams for these. I'm just going to do one for you. So which one would you like to see? Well, I mean like which letter? I'll do both, but just one letter. A? Okay. So do you feel like you understand the electron configuration pretty well? It's just the orbitals you really need help with? Okay, so if we're doing boron, then it's 1s2, 2s2, 2p1. Do you agree? Okay. So 1s2, 2s2, 2p1. Okay. This is kind of important. So S's, how many orbitals are there? Just one, right? So when I see an S, I'm just going to draw one space or one orbital. Okay, so I have another S, one space. I have a P now, so how many orbitals do I need? 3. So you have to draw 3 lines. Okay, even if most of them are blank, you still have to draw 3 lines. Then the exponent represents the arrow. So I need an arrow going up and an arrow going down. An arrow going up and an arrow going down. And since the exponent here is a 1, I just have one arrow going up. Does that make sense to you? So the electron configuration and the orbital diagram should correlate and be pretty much identical. The arrows represent the electrons. Yes, ma'am. Then 2 down. Yep. So you have to fill them singly before you can go back in pair. So you would go up, 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 down, down, if it was a 5. What other questions do you have? Anything? Are you absolutely sure? Okay. If you need more help, please visit our website. So let me show you where I'm going to post everything really quickly so that you're aware. Okay, so on our website, give me one last second. If you go to current unit, this is where I'm posting everything. So I've already posted the first answer key. I'll post the second answer key in a second. And I'm also going to put these videos on here. Okay, I'll put them up here in this section. All right. Have a good evening. Thank you for coming. You're welcome.